All right, so we're going to look at operations with functions. This is not a brand new topic. This is definitely something that's in Algebra 2. What you probably didn't do in Algebra 2 was talk about the domain. So that's kind of the new part. So we'll refresh your memory on the other part first. So functions can be combined using addition, subtraction, multiplication, and division to create a new function. So there's two different types of notation. If I'm going to add the two functions, f of x and g of x, I could say f plus g of x, or another way to write it would be f of x plus g of x. They mean the exact same thing. F minus g of x could be f of x minus g of x. Exact same thing either way you see it. F times g of x would be f of x times g of x. And to divide, I would have f of x over g of x. Another word for addition is the sum. So it would be the sum of the two functions. Subtraction would be difference. What do we use for multiplication? Product. And what do we use for division? Quotient. Very good. Make sense? Sound good? Awesome. Okay, so the domain. Here's how we decide what the domain is of our new function. The domain of the new function is the intersection of the combined functions. The domain is further restricted with the quotient function to exclude values in which g of x equals 0. Now it says g of x based on what we wrote above. What this really is meaning is the denominator. The denominator function, which in this particular case is g of x. Okay, that's why it actually said g of x there. So if I had to do g of x divided by f of x, then f of x couldn't equal 0. Okay. Make sense? So before we start, we are going to look at the domains of each of these functions, f of x and g of x. So this is a quadratic. That's what my parent function looks like. Even if I transform it, what's my domain? Good. Negative infinity to positive infinity. This is a line. Even when I transform it, unless I make it vertical, which that's not a vertical line, what is my domain? Good. Negative infinity to positive infinity. Okay. So the intersection of those two domains is what they have in common. So if you think about a street intersection, literally, intersection does not mean that something passes through. It's what they have in common. So the street intersection is that kind of that square piece in the middle where all the accidents happen, right? That's the intersection. So the intersection is what these two have in common. Well, they got everything in common, right? And so that is the domain of these three new functions for sure. Maybe the quotient function, but remember it said it's further restricted, so we don't know that for sure yet. But I can go ahead and say, all right, well, the domain here has to be negative infinity to infinity. I don't even know what the function is yet. The domain here, negative infinity to positive infinity. The domain here, negative infinity to positive infinity. The domain here, we'll revisit that in just a minute. Okay? So these three are already taken care of. Now I can just go and actually do the math here. All right, so I've got f plus g of x. So that means, and remember, anytime you substitute in anything with more than one term, you use parentheses. So this is going to equal, or let me say this first, sorry. This could be written as f of x plus g of x. Remember, it means the same thing. Okay, we're not going to rewrite it like that every time, but it could be that. So this is going to give me x squared plus x plus 3x minus 1. So I substituted in two things, both with more than one term, so I put in parentheses. Do those parentheses matter at all? No. Sometimes they don't. Here, they don't. So when I combine these terms, I get x squared plus 4x minus 1, and that equals f plus g of x. Everybody good with that? So for b, f minus g of x, this is going to be x squared plus x minus 3x minus 1. Do my first set of parentheses matter? No. Do my second set? Yes, totally. So this gives me x squared, then what? Oh, if I can, you can go ahead and skip to actually combining. What's x minus 3? Minus 2x, and then what? Plus 1. That equals f minus g of x. Skipping steps is totally fine. You just can't skip the first one, which is substituting in. Just substituting in and not doing anything, doing math there. And I already figured out my domain. F times g of x. So this is going to be x squared plus x times 3x minus 1. Do the first set of parentheses matter? Yeah. And the second set? Yeah, they both matter. So and when you multiply these, so I'm just going to do FOIL. So this will give me 3x cubed minus x squared plus 3x squared minus x. It'd be fine to skip that step too, which you should be able to do, I would hope. This is 3x cubed plus 2x squared minus x. That equals f times g of x. Okay, so the question was, do I not have to factor out an x? No, you do not. You don't have to go any farther because nobody asked me to factor or solve, right? They just asked me to multiply, so I multiplied, and I'm good. Does that make sense? Yes. No, it would be the same. As long as if you factor it and you factor it correctly, you're fine. Just don't take it even farther and solve and stuff, because then that tells me you really have no clue what they even asked you to do, okay? I understand that sometimes you don't know when to stop, and that's part of the problem. But if you feel like you can stop, stop. Because one more step, even though I'm quite certain you could all factor out an x perfectly, you could possibly mess up something simple, right? And then you've done another step you didn't need, and that's where you messed up, and then it's just a bad day, right? Okay, that's a good question. Anything else? All right, so let's look at the division. So this is equal to f of x, which is x squared plus x over 3x minus 1. Okay, so can I cancel this x out with this one? No. It's possible that I could actually still reduce something, but, and I do have a GCF in the numerator, so you can factor that out, x times x plus 1, because I know sometimes you don't see it until you do it, over 3x minus 1. So now can I cancel this x with this? No, because this is still addition and subtraction. I can't cancel anything. Like that, that's it. I can't do anything. So either one of these forms is totally fine. So I'll just say that this is equal to f over g of x, and I won't have to rewrite anything. First form was fine too. Like if you can tell you're going to factor it out and nothing happens, you don't have to factor it out. Right? Either form would be fine. But let's think about domain. This says the domain is further restricted with the quotient function, that's what this is, to exclude values in which g of x, or the denominator, equals 0. That means the denominator cannot equal 0. And it's not whatever you end up with, because sometimes, like I ended up with exactly what it is, but sometimes you can reduce. I don't care what you end up with. It matters what this is. So I need to say, well, all right, I know that g of x cannot equal 0. G of x is 3x minus 1. That cannot equal 0. Then you just solve it like you would if it said equals. So 3x cannot equal 1. X cannot equal 1/3. So here's where I'm going to make an exception to the interval notation, because we could write this as the domain is negative infinity to 1/3, union 1/3 to infinity. Totally fine. But if I have a few things I have to exclude, I end up with a bunch of those unions, and it's just like a lot to write. So we are going to, when you have to exclude like just one or two numbers, just a couple, then we are going to use set builder notation. So it looks like this. So it's little squigglies because it's a set. And you have an x with the vertical line, so that's read as it's the set of all x's such that x cannot equal 1/3. And that's what that domain looks like. We're kind of assuming that x is a member of the real numbers, but that's fine too, because that's what we're dealing with is real numbers right now. All right, what questions you got? All right, good deal. Let's see, I do want to do the rest of these. Okay, so let's look at example 2. I've got a quadratic here, and all that's happening is I'm shifting up 9, right? So that means that my domain is what? Negative infinity to infinity. Yeah, so it's all real numbers, but I'm going to write it like that. Then this is a square root function that's not transformed at all. Looks like that. So what is my domain? 0 to infinity. Do I include 0? Yes, I do. Okay. All right, so let's think about the domain. It's the intersection of these two. Do you remember at some point, quite often, I'm sure you did this like a lot, you have, let's say that 0 is right here, and you had to shade in the number lines. So all real numbers would look like this. It's like literally everything, right? And then 0 to infinity would be 0 to infinity like this. So what they have in common is where they overlap. That's literally what we're doing here. What they have in common is where they overlap. Where do they overlap? Right there, right? So that means for these first three, I know that my domain is 0 to infinity. And then the fourth one we're going to have to revisit here in just a second once we get there. Okay. I think that you probably already have the concept of adding, subtracting, multiplying, and dividing these functions, but we're going to still work through quite a few of these because we're going to make sure that you're not making up math, okay, as far as the other stuff is concerned. So f plus g of x, this is going to equal x squared plus 9 plus the square root of x. Do those parentheses matter? No, they do not. Is there really anything I can do? No. The only thing I should do is put it in the correct order with my exponents from least to greatest. So that would be x squared plus the square root of x plus 9. That's equal to f plus g of x. Bam. Okay. Everybody good with that? All right. So then subtraction, that's going to work the same way. Let's look at multiplication. This is going to be equal to x squared plus 9 times the square root of x. So here I'm going to distribute, right? So when I do that, that's going to give me x squared times the square root of x plus 9 times the square root of x. That's all I can do. That is f times g of x. Don't make up math. Okay. So then I'm going to divide. This is equal to x squared plus 9 divided by the square root of x. I definitely can't cancel those x's out, but what's wrong with what I have here? The square root. Can't have a square in the denominator, right? That's illegal. So I have to, do you know what it's called? Starts with an R. It's not reciprocal, but it's an irrational number, so I have to rationalize the denominator. Does that sound familiar? It's okay if you don't know what it's called, as long as you know what to do. So I need to rationalize the denominator, which means I need to multiply this by a value of 1. Whatever the square root is in the denominator, that's what makes this fraction, right? So when I multiply straight across, The numerator is basically just doing this. I'm multiplying this again, so that gives me x squared times the square root of x plus 9 times the square root of x. And then what is the square root of x times the square root of x? X. Can I cancel this x out with this one? Or any of them? No. That is it. That is f over g of x. Okay, so now my domain is further restricted by what I put in the denominator, which is g of x. G of x cannot equal 0. So the square root of x cannot equal 0. I square both sides and get x cannot equal 0. So the only thing that changes in my domain is that I no longer include 0, and it's just 0 to infinity. Bless you. What questions you got? Anything? Good. Because I'm dividing by g of x, and you can't divide by 0. The function would be undefined there. Alrighty, so now I've got this one. I've got cubic. So what's my domain? Negative infinity to infinity. And then I've got a quadratic. So what's my domain? Negative infinity to positive infinity. Okay. So all of these domains, negative infinity to positive infinity, negative infinity to positive infinity, and we will revisit the quotient when we get there. Okay? But we're going to start with C. We don't need to do A and B again. Let's start with C. So I'm going to multiply them. This gives me 2x cubed times x squared minus 4x. Okay? So then when I multiply them together, I'm really just distributing. So 2x cubed times x squared is 2x to the what? 5th minus 8x to the 4th, and that is f times g of x. All right, so then let's divide. This gives me 2x cubed divided by x squared minus 4x. Do not just start canceling stuff right here. That's why you do weird things when you're not supposed to, because I don't think you fully comprehend when you can do what. So mathematically, my next step would be to factor out a GCF if I have one, which I do. So this is going to give me 2x cubed divided by x times x minus 4. Right? Now can I cancel stuff? This is being multiplied here, right? So since these two things are being multiplied and there's just one term up here, I can cancel this x with one of those, and that becomes x squared. That is legal. So then that gives me 2x squared divided by x minus 4, and that equals f over g of x. Now, to revisit my quotient, remember, what I divided by, which is g of x, cannot equal 0. I do not care what my denominator is right now. It's g of x. So when I come back over here and I say g of x cannot equal 0, g of x is x squared minus 4x. It cannot equal 0. So basically, I need to solve it like it said equal. So I'm going to factor that x out again. I get x times x minus 4. Cannot equal 0. I have two factors here. Don't forget this guy. X cannot equal 0 and x cannot equal 4. So since it was all real numbers, this is now the set of all x's such that x cannot equal 0 or 4. That's what my domain looks like. What questions you got? We good? All right, let's look at example 4. So you probably don't know what these look like just yet because we haven't really gotten there yet, but there is some stuff you know about it. What do you know that x can't be here? 0. So the domain, I'll just tell you, that's the only thing that's wrong with it there. Set of all x's such that x cannot equal 0. Here, what can x not equal? -2. So set of all x's such that x cannot equal -2, because your denominator cannot be 0. You see that poster over there? No, because when 0 is in the denominator, it's undefined. No. Okay, it's okay for the 0 to be in the numerator. Check up there if you need to. All right, so there are my restricted domains. So then this is the intersect. I need the intersection of the two. Where do these two intersect? If I have all other numbers besides these two, right? So basically I can use everything but these two numbers, right? So my domain then is the set of all x's such that x cannot equal 0 or -2. Same thing here, domain. Set of all x's such that x cannot equal 0 or -2. And then we will revisit this one when we get there. Okay, everybody with me so far? So we are going to go through all 4 of these so that we make sure that we actually know how to handle fractions correctly. So when I add them, I get 1 over x plus 2 over x plus 2. When you add fractions, what do you have to have besides 4th grade skills? Common denominator. So what would my common denominator be? Well, it's going to have to be, I'm just going to multiply these. It's x times x plus 2, because I can't just add a 2 to the denominator. So my common denominator is going to be x times x plus 2. That's the easiest way to get a common denominator. Might not always be your least common denominator, but in this case it is. All right, which means this first fraction has to be multiplied by x plus 2 over x plus 2. So x plus 2 times 1 is x plus 2. Plus, this one has to be multiplied by x over x, 2x. So that gives me 3x plus 2 over x times x plus 2. I don't even have to multiply. Just like on the other one, I didn't have to factor. I don't have to multiply, so I'm not going to. I've got to clean up the numerator. I'm just going to leave it because maybe I need it factored out. Who knows? That's fine either way. That's it. Can I cancel this x with this x? Can I cancel the 2's? Nope. That is f plus g of x. All right. Then I have g of x, which is 2 over x plus 2. See, this is g minus f. Minus f of x, which is 1 over x. Again, besides 4th grade skills, what do I have to have? Common denominator. My common denominator, once again, is going to be x times x plus 2, or x plus 2 times x. It really doesn't matter. So this has to be multiplied by x over x, so that gives me 2x, minus, then this has to be multiplied by x plus 2 over x plus 2. This is x plus 2. My denominator is still x times x plus 2. My numerator is going to be what? X minus 2. That, and then can I cancel these 2's? For the x's? Nope, that's it. G minus f of x. We good? All right. Then I'm going to multiply them. G times f. So that's going to be 1 over x plus 2 times 1 over x. Besides 4th grade skills, do I have to have a common denominator? It's 2 over x plus 2. Thank you. Besides 4th grade skills, I need to be able to write it down correctly. Do I have to get a common denominator? No. Multiplying fractions is easy. You just multiply straight across. So it's going to give me 2 over x times x plus 2. Can I cancel those 2's out? No. G times f of x, that is my answer. So now I have f over g of x. F of x is 1 over x over g of x, which is 2 over x plus 2. So I have a fraction and a fraction. Am I supposed to freak out and quit? No. From 4th grade, we know that when you divide fractions, what is your rule? Say that again. No, say it. What did you say? I couldn't hear you. Yeah, keep, change, flip. Okay, that's fine. I just couldn't hear you. You're kind of muffled. That's fine. No, I'm sorry. I just couldn't hear you. Keep, change, flip. So you keep this one, you change it from division to multiplication, and you multiply by the reciprocal. So this becomes 1 over x times x plus 2 over 2. Do I need a common denominator? No. You multiply straight across, and you get x plus 2 over 2x. Can I reduce that at all? No. That is equal to f over g of x. Now I have to revisit my domain, right? G of x, because that was my denominator, right? G of x cannot equal 0. So 2 over x plus 2 cannot equal 0. So to solve that, I'm going to multiply both sides by x plus 2. I get that 2 cannot equal 0. Is that a true statement? Yeah, 2 can't equal 0. It's a true statement. So I got a true statement. That's good. But I didn't get an x can't equal something. And the reason is because that function, it's never going to equal 0 anyway, so there's not a value it can give you. So since I got something like this, there is no change. The domain is still just the same. Like there's not an additional thing to put in there. So it's a set of all x's such that x cannot equal 0 or negative 2. Okay. What questions you got? Because it's the same with a further restriction, and there's no further restrictions. And so even though I know that like 0, this can't equal 0, but it also can't equal negative 2, I know that doesn't make the denominator 0, but it has to do with the original function. Okay. What else you got? Anything else? All right, so let's look at this next one here. So both of these are square root functions, right? I know that they look like this. This one has been transformed. What has happened to it? Left 6. What's happened to this one? Right 2. Just by knowing what your parent functions look like and those easy transformations, is that going to make figuring out the domain really easy? I don't have to do any work. What is this domain? Negative 6 to infinity. Do I include negative 6? Yes. What is this domain? 2 to infinity. Make sense? See how sketching something, I didn't plot any points. I didn't make it look beautiful, but I know what those points are supposed to be from that, and I can figure it out easily. All right, so then where they intersect. Where do these intersect? 2 to infinity, right? If you were to draw your little number lines, 2 to infinity. So the domain 2 to infinity. Domain 2 to infinity. Domain 2 to infinity. And this one we will revisit in just a moment when we get there. But we are going to work through these to make sure that nobody is making up math with square roots. Okay, so if I add them, this is going to give me the square root of x plus 6 plus the square root of x minus 2. Does that give me 2x, the square root of 2x plus 4? No. You can't add what's underneath there because it's like adding x and y, and that's it. I can't do anything else. That's g plus f of x. The same thing happens for subtraction. Square root of x plus 6 minus the square root of x minus 2, right? So I can't actually combine them. Can I distribute this negative? No, because it's not parentheses. This is equal to f minus g of x. There you go. So then we're going to multiply them. Square root of x plus 6 times the square root of x minus 2. Can I actually do something here? If I had, you can always multiply and divide everything that's under the square root. You can't mix and match though when, with addition and subtraction. So here, even though there's not parentheses here, I need to kind of think about it like that. And I'm basically just going to multiply those two binomials. So it's going to give me the square root of x times x is x squared. Then negative 2x and a positive 6x is a positive 4x minus 12. And I don't care what numbers are under there that have perfect squares or whatever, you don't get to divide up that square root and take the square root of x. Big fat no. Okay, can't take the square root of that. I don't need to factor it. That is g times f of x. That's it. Then f over g of x. This is equal to the square root of x plus 6 over the square root of x minus 2. Do I get to cancel those x's? No. If I couldn't do it without square roots, I can't do it with square roots. But what's wrong with this? Square root in the denominator. So I need to multiply by a fraction of 1 made up of whatever that square root is in the denominator. So this is x minus 2 over the square root of x minus 2. So when I multiply the numerator together, that's basically what I just did right here. So I know in the numerator, I get the square root of x squared plus 4x minus 12, because I already did it, over, what do I get in the denominator? X minus 2. Square root of a monkey times the square root of a monkey is a monkey. So this is equal to f over g of x. That is my answer. Cannot reduce anything. Then I need to revisit my domain. I know that g of x cannot equal 0. That means the square root of x minus 2 cannot equal 0. I square both sides, and I get x minus 2 cannot equal 0, so x cannot equal 2. So the only thing that changes in my domain is that I don't get to include 2 anymore, and I go from 2 to infinity. Okay. What questions you got? Alrighty. So we're going to evaluate now. So I don't want f plus g of x, I want f plus g of 5. So when I write these down like I'm going to add them, I can go ahead and substitute 5 in for x. So my f of 5 would be 4 minus 5 squared plus g of x, which is 2 times 5 plus 8. Right. So then this gives me 4 minus 25 plus 10 plus 8. So 10 plus 8 is 18 plus 4 is 22 minus 25. I get negative 3. F plus G of 5. Quite sure you did these as well. All right, so you go ahead and do B. No, because this is just an evaluation, so it's not a function that would have a domain. That's a good question. Okay, so I did every single step But again, thinking smarter, not harder, but then you got to be careful not to get ahead of yourself and assume things wrong. But if once you're here and you see that, oh, well, that's going to give me a positive 4 and 4 minus 4 is 0, does it really even matter what's happening here? Nope, because 0 times whatever that is going to be 0. You're done. Okay? What questions you got? Anything? All righty.